I'm joined by Mike Darby, co-founder and CEO of Demand Logic. Thank you so much for joining me, Mike.
Thank you, Daniel. It's a pleasure. Thanks for having me.
Oh, great. Glad you can make it. And the way I like to typically start these conversations is really just learning about the problem that you and Demand Logic are solving. And then I feel like that's a really great way to just set the tone, and then we can take it from there.
Sure, thank you. Well, yeah, so the problem that we're solving, or we've set out to solve, is one that I think is not very well known to people outside of large buildings. Or rather the operation of large buildings, that is. And you have an expectation when you go into a big shiny retail outlet or a big corporate HQ or something, that the building is super efficient, running beautifully, everything's gleaming and fantastic. But the reality of what's happening behind the scenes is usually very different. And the problem really is about complexity. So in a lot of those buildings, believe it or not, I mean, they're massive energy consumers. They use a huge amount of heating and cooling.
Mm-hmm.
The UK, I mean, and Northern Europe has some particular climate challenges, funnily enough, because we have this kind of schizophrenic climate where we often don't know if it's heating or cooling mode, if it's summer or winter. The kind of shoulder seasons, we just don't know what's going on.
Yeah, it's very true. I remember just on that. I remember when I first moved to London, because I'm originally from California. Someone that I was working with told me that to dress like a Londoner, you need to, first of all, it's layers, umbrella, and sunglasses. That's the way to do it.
That's right. Absolutely. Yeah.
So, it's constantly changing.
Yeah. Prepare for everything.
Exactly.
And I mean that, in the same way that we get confused by the weather, buildings do too, because there are systems that have heating and cooling in them. And to give you an idea of scale, we found a single London office building. This was in March 2018, so it was actually when the beast from the east was hitting Europe.
Oh wow, yeah.
And we had the coldest March day on record. We plucked this day out because it was particularly noteworthy. On that day, this particular large office building was actually supplying cooling to a third of its spaces. And if you kind of look at the numbers there, the cooling that it was applying to a third of its spaces was the equivalent of the total energy consumption of around 600 UK homes. That's the total energy consumption. But because it was cooling the spaces on a cold day, obviously it needed a load of extra heating to combat that. So it then was running additional heating capacity, the equivalent of another 500 homes. So you're looking at kind of 1,100 homes that's not the energy consumption of the building, that's the pure waste, the evident waste. And the reason this was happening and going unnoticed is because there are, in this case, tens of thousands of tiny energy consumers in the ceiling void, so hidden away, and they're competing with one another. As an occupant of the building, if the temperature averages out to something that's comfortable, then you're not aware of that. There's no complaints because the cooling has been overcome by the heating, so the temperature comes to 21, 22 degrees, you're happy. So this problem is going on and on, often unnoticed. It's only noticed in your energy bills. And so one of the challenges there is that really in corporate real estate, energy is, whilst it's a colossal amount of money for any building, in our terms, as a kind of member of the public, in terms of a corporate spend, energy is around about 1%. So it's not a massively high priority, other than from a sustainability perspective. It's really not a major cost issue. So these situations have come about, and they are, I'm afraid to say, kind of endemic in buildings of this nature. And it's all down to the complexity and how hard it is to find these needles in the haystack, I guess.
It's crazy to think. I mean, it seems really straightforward, at least, sitting in your flat or in your house, you wouldn't turn on the air conditioning and the heating at the same time.
Yeah.
But I guess what you're saying, and that's what you were mentioning about, you're using the word complexity, is because it's such a big building.
Yeah.
And it's just impossible to really tell where things are going and kind of what's going on a grand scale. Sometimes you're cooling down a certain part of the building because that's just maybe it's automatically on or something, and then someone says, "Oh wow, it's kind of cold in here," so they turn on the heater.
Yeah, yeah. There's a multitude of reasons, but some of the most common are human. So
Right.
when a building is completed and handed over, and occupants come in, there's an assumption, and these assumptions are in specifications everywhere, that we'll all be happy in an ambient temperature of 21 to 23 degrees C. What that doesn't take into account is kind of individuals are different, and that's one thing. But also that depending on where you're sitting in an office, if you happen to be near some ventilation and the air is blowing over you, you will feel cooler, even though the temperature sensor says the temperature is appropriate. You will feel colder. So when the complaints start coming in, somebody will inevitably ring down to the FM team, the facilities management team, and they'll say, "I'm too cold." What happens is somebody will adjust the temperature remotely via a building management system. This is a complex system of embedded computers that are actually controlling all of these things. Very, very clever, and enormous potential to save energy, but
Mhm.
also enormous potential to waste energy if you kind of get it wrong. So often the immediate reaction is just simply to turn up the set point, the temperature set point, because somebody's complained that they're too cold.
Right.
Because you're in an open plan office, you have loads of systems adjacent to one another. As soon as you start overheating one area, the surrounding areas will go into the opposite mode, and they'll start cooling. So one by one, there's a kind of spiral of deterioration of how the building's operated, because the complaints lead to more complaints. So that's one of the human factors that
Wow.
affects that. So identifying, there's a real proxy when we first look at a building to see what the likelihood of this problem is. And that is, you just look at all of these set points in the building, and you could be talking about thousands, in a big office building, that, there are thousands of individual controls in the space. So you look at the spread of those, and if there's a significant spread, then that's your first alarm bell that there's a challenge in the building, and that discomfort has led to potentially the wrong action.
Huh. And so what and how does demand logic step in here and actually solve this? Because it sounds, I mean, it sounds like a person can't really do it, in the sense that there's just so many factors and variables. You would really need a computer system to be able to track all of that.
That's the thing. So what these buildings do have, as I mentioned, is a thing called a building management system. This network of embedded controls, and they are clever. They are, they're designed exactly to do what I'm talking about: control the space to whatever target you want. But because there are so many of them, this was my old job before Demand Logic.
Mm.
I was somebody who was designing, installing, commissioning these systems, and then potentially sort of going out to have a look when there were problems with them.
Hmm.
And because there are so many different points of reference, you just don't have time as a human to go and check every single one.
Right.
So you're using hunches and you're using complaints to try to guide you to the problem. And one of the reasons why Demand Logic came to be was just that, it's kind of obvious, these days you've got a digital system that's generating data, but you're not storing and collecting the data, and you're not analyzing it, you're just throwing it away. So,
Mm.
you're getting a human to look at it, in real time. That's not what you need. You need something that's going to not get bored. Something that's going to look at that data over the full 24 hours of the day, ad infinitum. You look at the changes, you look at what's deteriorating and what's not. And it can, just by using the analysis that you get from that, you can deal with these problems in a prioritized manner. I mean, the problem we're talking about first there is simply a human one. That's a perception and the wrong action. But there are many others as well, and some of them are kind of more physical. So, for example, we talked about simultaneous heating and cooling. In every space in a commercial building, there'll be, lots of air conditioning units that can do both heating and cooling, and usually you have two little valves on them. And each of the valves has got a little motor on that can drive it open and closed a certain amount, however much you want,
Hmm.
to control the space. But these things get old, they deteriorate, the valves get stuck. If a heating valve gets stuck open, then it overheats the space. So the system goes, oh, I need to do some cooling to get the space to the right temperature. And if it's successful, it does get the space to the right temperature. Those things go unnoticed. Again, it's this, you're literally hemorrhaging energy. If you wanted to invent a machine that would waste as much energy as possible, you'd struggle to do that effectively. So there are all sorts of mechanical reasons, so physical reasons why these problems happen. but the teams who are sort of tasked with looking at those simply don't have time to look at them in a prioritized manner. There's kind of old saying in the maintenance world, which is that you're either too early or too late when you're maintaining something. You're fixing stuff that isn't broken, so you're too early, or it happened 6 months ago and you've had that problem for 6 months. But if you can do it in kind of near real time, picking out the worst offenders in near real time, you can save that waste of energy really quickly and jump on it.
And so demand logic could actually find one of those, just to the specific example you're mentioning, it could actually see, oh, this little motor is potentially broken because there's constant hot air.
Yeah, exactly. You see the outliers in those systems. Actually, there was a nice example in a very early project that we did. So this is where we came up with the phrase "the needle in the haystack." There was a little case study on it, but it was great because we were at King's College London. So we deployed our system across their campus. One of them was the Strand campus. So lots of buildings, loads and loads of complexity there. And in one of the buildings, the chilled water is similar to the story I told you before, but the chilled water system was coming on at night. This is a building that had no servers or anything like that, where sometimes you see cooling requirements at night because you have server rooms, things like that. This was just for comfort. So nobody knew why the chillers were coming on at night. So we looked, and this was in the middle of winter as well. So we looked at the platform. We said, well, you have a really high heat gain in this one office on this floor, So the next day, the team went and had a look in the little office, and what had happened is someone had come in. They'd been too cold. They brought in a fan heater from home, turned it on, left it on, and gone home again. So the fan heater was overcooking the room, which was bringing on the cooling. Now the things that's a kind of simple mistake, and it's completely understandable as a member of the public. But what the hidden stuff that people hadn't seen, that they won't realize is happening, is that once the cooler comes on in the ceiling, it's not just the fan in the ceiling. The fan on the ceiling has come on, it's asked the system for chilled water. So chilled water is generated by a giant machine in the basement, a chiller. It's enormous, it's the size of a car. So that machine is running. And to get the chilled water round to the system, there are pumps, and each pump is 15 kilowatts. That's say 30 times the average load of a house. So you're talking about, just to serve that one room, you have to run up a whole load of overhead, just to get that just to get that one room cooled down. So the wastage there is absolutely massive. But you'd be completely excused not to realize that as the individual brought in a fan heater.
Yeah.
Just a bit chilly.
Yeah, I would never consider I didn't know any of that in terms of how much is required just to turn on the AC. That's what it is to me. Just turning on the AC, just kind of press the button and then it just sort of magically happens. Or in this case, it's just set. There's a thermostat clearly, and it's just set to maintain a specific temperature. So it sounds like the issue here is, well, first of all, there's the financial one to the buildings, which is, it takes so much energy to actually heat and cool a building, and if it's done unnecessarily, then basically you're spending a lot of money on doing things that aren't necessary. And then of course there's the environmental implications of using or wasting energy.
Yeah, and it's really considerable in commercial buildings. I think the building stock as a whole is something like 18% of UK emissions. It's something in that order of magnitude. And
buildings are 18% of the UK's emissions.
Yeah.
Wow.
I should probably double check.
Yeah, we can double check that and put that in the show notes. But yeah, that's
it's that order of magnitude. I mean,
even if it's 10%.
If you imagine, pardon?
Even if it's 10%.
Yeah, exactly. Yeah. It's really significant, and it is again understandable. But these are systems that with a building services background, if my job was the engineer who's trying to make things operate appropriately.
Yeah.
And as a building occupant, you only ever notice those systems if you're unhappy. You simply don't realize they're there if they're working effectively and well. So, in the building services world, you can only expect a call when something's broken. So it's very, very difficult to sort of keep on top of these things and to make things work effectively and efficiently. And I think one of the challenges with the response to hot and cold complaints, like in the first example we were talking about. I think in the building services world, people the expectation of building occupants is really that they should get what they want, understandably, because we're used to sitting in our house, and if we're a bit cold, we just turn the thermostat up a little bit. So there is a little bit of education required, I think, to kind of get people to that understanding that if you're in an open plan office, you're going to have to accept that a temperature within certain tolerances
Yeah.
is okay. And if you are generally colder than other people, you just dress slightly more appropriately and so on. Wear a jumper to work.
Yeah, exactly. Um, well, yeah, I mean, what's interesting is, first of all, the more we're talking, the more I'm starting to really see the power of demand logic, because it seems like before this kind of technology, and that's what you were saying earlier, people are basically, people who are servicing the buildings, just are running on a hunch, and it's almost like no news is good news. So if no one's complaining, then there's really nothing to fix,
Yeah,
particularly unless there's an obvious problem. And again, you'd have, especially in a really large building. I know that, um, like one new change, which is this massive mall by St. Paul's, and I've been there a couple of times. It's huge, and yeah, I mean, unless someone says something, there's just no way you'll be able to really, in real time or even near real time, know that something isn't working. And especially in a new building, uh, you'd expect everything to just be fine. So it's almost like it's a special, almost like a magnifying glass, or this like special ability to just see what is and what isn't working.
exactly. And one new change, just to give as a good example, so the systems that I'm talking about that we're analyzing the data
Yeah.
from. So the data we're analyzing, if it wasn't clear, is we're not generating that data. We're not adding sensors into a building. What we're doing is looking at the systems that are already installed, the
Mm.
data that they are generating. And in one new change, the data is coming from things like the obvious things like temperature sensors, humidity sensors dotted around the building, but then the less obvious things like the signals to these valves I'm telling you that are in the ceiling void, so whether to open or close and so on. And also the settings that users are putting in, so
Mhm.
adjustments and so on. Um, when you start adding up all of those points, at one new change, I think you're at over 200,000 data points that are generating information in real time. So when you start thinking in those terms, what we're asking people operating the buildings to do is to make sure the 200,000 different settings and feedback information points are working harmoniously. And it's absurd. You can't expect to do that as a human.
No,
That's why computers were invented, was to crunch data like that.
exactly.
So I think that was. It's funny. I was once asked what made you become an entrepreneur, and I kind of laughed because I'd never considered myself to be an entrepreneur. So I decided I replied that I guess I'm a reluctant entrepreneur. It's like I and my co-founders did this because we were so annoyed that there wasn't a system available that was helping us diagnose these problems. So so we made one because there wasn't one. It wasn't that we saw a big market opportunity.
Yeah.
But
Like,
seeing firsthand that waste and the frustration of not being able to address it is kind of how we came to be.
I think that's a really good way to start a business, is to basically to serve your own need. If you're there thinking how there has to be a better way,
Yeah,
and we're just going to essentially invent a solution. I guess that is the, kind of the market need, or seeing a gap in the market, because you're trying to solve something. You're just thinking, I can't do it, so I'm,
yeah.
I'm just going to make it my own way. And I thought it was really interesting. I saw that, you, with demand logic, you're able to actually help companies save up to 40% on their energy bills. So I mean,
Yeah.
the solution you've made is incredibly effective.
It is. I mean, it's a sad truth, but the fact that you can save that much really means that there is that much waste. This is the unfortunate thing,
Yeah, that's a
but
good
it
point.
is. I am really sympathetic, and with the people running these buildings, it's incredibly hard. And what I was touching on before about the reactive nature of FM, where often the FM teams are just getting beaten up for
Yeah,
things, you know, people being unhappy and too hot and too cold. So they're often acting very reactively. You know, all of their time is used up responding to hot and cold complaints and so on. So if you can get ahead of the curve by, you know, ahead of those complaints by
Yeah.
addressing the problems before people have complained, you know, this is where we've had some great results. You start fixing problems, energy savings come immediately. But what, you know, the thing that was slightly unexpected for us, I suppose we should have realized this, but it was great to see, is that hot and cold complaints start dropping off as well. Because
Yeah.
if you're fixing the things that are wasting the energy, almost inevitably you're going to actually make people more comfortable in those spaces. And it's a really great information to give to the likes of, you know, in a lot of these buildings, for a lot of corporates, they'll have different teams, you know, of energy managers and facilities managers. And there's often been a little bit of a tension between those teams, because there's a sense that an energy manager is just going to tell me to turn everything off and then everyone will complain, you know. So I'm not, you know, I'm really worried that there's an energy project. And what's great to come out of our experience is just giving the lie to that. It's like, no, this is in everybody's interest. Let's just get this stuff fixed. You get it fixed, you save energy, you reduce hot and cold complaints. If you reduce hot and cold complaints, the maintenance team are now not on the back foot. They can start being more proactive. So then they can get even more ahead of the game. So there's a real opportunity to kind of streamline systems, streamline the use of your human resources. And interestingly, you know, one of the things we added onto our platform was a bit of a kind of social interaction. So you can communicate when you're looking at some of these faults. You can imagine for the general public, it's not the most exciting social engagement, talking about fan coil units. I happen to like it. But what another unexpected thing to come out of that was that part of our role there is, you know, we're trying to help our customers in a transition from planned maintenance to data-driven maintenance. You know, don't go and fix things that are clearly working perfectly well.
Right.
But in doing that, we provide feedback, you know, on the platform, just from a human perspective, you know, saying that's a great job, that thing's fixed, and that's saved, you know, £5,000 per annum and a significant amount of carbon. You know, well done to the FM team. So the FM team are now getting kind of credit where previously they were kind of only getting beaten up when things weren't working. So that's had, you know, in some cases, quite an effective boost to morale, which I'm really pleased to see. You know, having been one of those guys, you know, who's getting beaten up, it's nice to kind of bring this out into the open a little bit more, because the complexity of it is not well known, other than, you know, in some more trendy bars where you've got all of the building services exposed in the ceiling now.
Right.
So you can start to get an idea of what's going on. But no, some interesting and unexpected results came out.
Yeah, that's a really cool kind of secondary or sort of unintended consequences in a good way, where you're able to your teams are able to work more effectively and efficiently. And which means that they're not focusing their time, kind of like you said, on this big backlog of issues, because they're actively prioritizing and moving forward with that, with the things that need actual attention, rather than just doing planned maintenance, because that's the only way to really make sure that you hit every single spot in a building. I think it's really cool what you just said about your software is actually able to tell you that you saved £5,000 and XYZ amounts of carbon.
Yeah. I mean, we provide in the first instance some pretty robust estimates. So, you know, we tend to call it cost avoidance rather than a saving, because, for example, if you find something that is suddenly started operating in the middle of the night, you know, unexpectedly, and you stop it happening, if you stop it happening the next day, people aren't going to see a saving on their bill the next year. But if you've avoided the cost that they would have had, you know, would have ended up paying if that went unidentified. But yeah, so we have some pretty robust estimates on that, and we back it up with kind of meter data where necessary. So, you know, with the usual challenges of metering for things like heating and ventilation, you have to take into account, you know, outside air temperature and things like that. But yeah, so sorry, that's a waffly answer, but yeah, we do make some pretty robust estimates on what people are saving. And that's again, you know, one of the things that we've learned as the platform has evolved, is trying to draw people in more and give them the fruits of their labor. So we've recently changed the platform. There was a bit of a hidden bit of gold, which was showing you how well you've done over time. You know, it
Mm.
kind of shows you in a strata how the actions that you've carried out have had a significant improvement and how the savings have come out of that. So we brought that right to the front of the platform now. And I think we've had some great feedback about that, because a lot of people didn't even realize that was there, you know.
Yeah, people love to know that the work they're doing is working, and they're somehow rewarded for it. It becomes a really simple metric or KPI that they can track to make sure that they're actually focusing on the right things. And
Yeah. Yeah.
yeah, it's like any app that you start, if you're gonna, I don't know, go on first thing that comes to mind is like a dieting app or something, and you start kind of tracking your new eating habits, and you get little rewards and medals, and even though they're meaningless, just the points in the app make you feel good. You just want to win stuff.
Yeah. Yeah.
So putting those kind of
Yeah, that's absolutely right. And you know, one of the other things that we introduced was something again that we felt was missing from the industry was a kind of operational performance metric. So scoring a building and how well it's actually working. And there
Mm,
are other things, you know, that there are specifically energy targets and things. You know, like in a domestic building, you have an EPC, an energy performance certificate,
yes.
gives you a kind of A to H rating.
Hmm.
Well, such things apply to commercial buildings as well, but they're very broad and they can be quite misleading. Um, you know, we saw some information from the Better Buildings Partnership, which is a kind of consortium of lots of the big real estate owners, and they found that there was almost no correlation between an EPC and actual energy performance. Believe it or not, it's quite staggering.
So what? So because I'm familiar with the letters, but I don't actually know what EPC, what it in reality means.
Just energy performance certificate. So you get a rating based on a number of things, you know. So in the first instance, it's how the building is designed and how it's expected to perform. So if you
Hmm.
put in energy saving features, you get a better score.
I see.
You know, if you design it, the systems to operate in a certain way, you know, your score improves. And one of the problems that the Better Buildings Partnership identified was that that really doesn't seem to reflect how the buildings actually work in reality.
Oh wow. Okay.
And it's a real big problem. But what we saw was that, you know, bearing in mind that all of this data I mentioned is being generated all the time by these buildings, but not being analyzed, not being assessed. It's like, well, if you gather all of that and you come up with robust metrics on what good performance looks like, then you can have a live benchmark score. So we started creating that. Well, not started, we've been running that for a while, and we're kind of improving it all the time.
Hmm.
And we're looking to kind of collaborate in the industry to find the best ways of scoring. But what that has been really effective for is if you put it in front of your customers, let's say a monthly meeting with a scorecard of all of their buildings. So, you know, maybe they've got 10, 20 properties that we're monitoring, get the teams in there and you see the scorecard together. That is quite a motivator. So obviously whoever's on top gets the pat on the back and gets all the credit. Who's ever on the bottom gets stared at for a while. And you do find at the bottom, you know, the bottom keeps coming higher. So even without having to make kind of arbitrary benchmarks, you just start pushing up, you know,
Yeah.
get the worst one up, and then they'll all start staggering to the top. So we've seen some really great results there. You know, we struggled early on with our platform with engagement with customers. You know, we hadn't found exactly the right way to get our information to them, you know, and
Hmm.
how to engage with the teams. You know, you imagine you're trying to get a team that's already on the back foot, you know,
Right.
chasing reactive calls, and you say, here's another system for you to look at. The instant reaction, understandably, is that I've got enough to do already without looking at this thing.
Hmm.
So we had to find a way to get everyone to realize that, you know, your life will eventually get easier. Not eventually, your life will fairly quickly get easier if you start hitting the worst offenders first. So by using this scorecard approach, you know, there's a little bit of psychology in there, but if you're coming into a monthly meeting, knowing that, you know, your building has improved dramatically from last month, it's a good place to be. And likewise, you know, if your building's deteriorated, you know, let's drill down together and find out why that building is going down.
Yeah, one thing that I'm thinking about as you're mentioning this is a lot of the people that I've been speaking to on the podcast, they are either certified B corporations, or they have, an ISO certification where they're talking about how sustainable they are, and a portion of that is down to actually the building that they work in.
Yeah.
So I was kind of thinking, what happens if Because I can definitely see the carbon savings if the energy that the building is using is coming from fossil fuels, for example. What happens if the energy is, the building's really forward thinking and they say all electricity that we use in our building comes from renewable sources. It's all green energy. Um, from a carbon saving standpoint, I guess there's less, that kind of issue goes down a little bit, and it becomes more about the cost avoidance, as you were saying, with using demand logic. That's where it would fit in.
It does, yeah. So that's part of it. So there's the cost avoidance from energy costs. So even if you are obviously procuring renewable energy, you're still
Yeah,
paying for it. So
right.
you can save that cost. The stuff we talked about with comfort and well-being, that's a big deal, So there's loads of academic research about how the office that you're working in, affects your productivity.
Yeah,
So
yeah,
we kind of really cheekily created a cost proxy. So if we look at we use some academic research. We use them at UC Berkeley Labs, funnily enough. I think it was a meta study of nine countries where they looked at the productivity of individuals in different types of work and how that productivity was affected by temperature in this case.
all right, okay.
So because temperature sensors are very numerous on BMS, that's a great starting point. You get all that stuff free. So
BMS is the building management
yes, sorry.
software. Okay.
Yes, a building management system. So this is the all of the little things that are controlling the heating, ventilation, air conditioning, and so
Got
on.
it.
So there are usually like loads of temperature sensors available. In somewhere like One New Change, there's 1,500 temperature sensors or more. So what you can do is you kind of estimate the number of occupants, and we do that we kind of count air conditioners. We use lots of rules of thumb. Yeah, I really like this approach, because you can correct this information if it's wrong, but we kind of throw it out there early on to try to get some engagement. So we estimate the number of occupants. We use whatever the average regional salary is for where the building is, and we look at the output of this meta study, see how productivity decreases when the temperatures are outside the tolerances, and we come up with a number, in pounds of this is how much money we reckon you're going to lose from unproductive staff if you don't fix this problem. Now that pound number usually higher than the energy number by an order of magnitude or so. Now that obviously isn't a number that you're not going to bill anyone on that. You're not going to hang your hat
Right.
on. But we are conservative at every assumption in that calculation. So the reality is probably higher, but it's a really good way of getting the attention of the CFO in a corporate,
Hmm.
because we touched on this earlier, but energy is typically 1% of their spend. People are 90% of the spend for an average corporate. So you start talking about getting the people happier and working better, and there's a great return on that. So that's part of it. Sorry, we were talking about if you had a building that was fully powered by renewables.
Right.
There is another more hidden sustainability benefit to what we do as well, which is there's unexpected things. So even if you're being supplied by zero carbon electricity, you have a chiller, this big car-sized machine in the basement that's kind of grinding away there. Now, again, as an occupant of a building, you're not going to see this, but you just get cool when you want it to be cool. What you don't realize is that chiller could be running very efficiently, or it could be running extremely badly. For example, a machine that size, unlike your fridge at home, doesn't like turning on and off on a regular basis. It should be on and gently modulating to match the load. Often that's not the case. They're not doing that. They're kind of turning on and off far too frequently. Now, the life expectancy of that machine will be massively reduced if it's operating like that.
I see.
So you end up having to replace it, which is it's hundreds of thousands of pounds replacement job, but the carbon impact of changing those things is actually huge.
Hmm.
The amount of work to do that. If you're talking about a central London office, replacing a chiller, often you're talking about shutting a road to get a crane in at the weekend. That's the
Wow.
kind of scale of the job. If you can push that replacement out by 3-5 years, that's a really significant saving, obviously, of cost for their customers, but also the carbon impact, the embedded carbon of replacing equipment that shouldn't have needed to be replaced.
Yeah, it's a really good point. That's something as well. It's another pattern I'm hearing in terms of what exactly is environmental sustainability, and oftentimes it's just making things last longer.
Yeah.
because to build a whole new, in this case, chiller, one of these massive machines, the amount of energy, also known as carbon emissions, basically, as well as getting the metal and all the materials that go into it, is enormous. So if you're able to make it last, like you said, 3 or 5 years longer, that makes a lot of sense. I think that makes a lot of sense. So in terms of who demand logic is for, it's all really for commercial buildings, meaning like big skyscrapers or malls, or I guess the bigger the better in that case.
Bigger the better in terms of the rapid impact. But
Mhm.
but we're actually, you know, expanding in areas we hadn't aimed at. You know, that was our target market in the first place because,
Yeah,
well, one, the bigger the building is, the harder it is to manage because it's so complex, you know. But we're actually working really well in universities now,
cool.
telcos, and just recently we got a contract with the NHS, so we're going to be installing in 3 hospitals.
Wow.
You know, so hopefully we can make a significant impact on their energy bills. They obviously, you can imagine, they have really significant energy bills.
Yeah, but
We can start making some big dents in those. That'll be great. You know, it's a quite a rewarding environment to work in.
on a more personal level, just as because I'm conscious of time here. What one question I like to ask more for inspiration is what do you do personally? I mean, so you're doing this incredible work of helping businesses, or rather large buildings, save on their carbon emissions and therefore their money. So, but what do you do personally on a day-to-day basis to be environmentally friendly, whether at home or at work or in between?
Well, there's the obvious one, which is being an engineer. I've obviously put some ludicrous central heating system in that I'm trying to get as efficient as possible, much to the irritation of my wife as I keep fiddling with it. So there's that. But no, the things that actually make an impact, I guess. I mean, I cycle to work as much as I can. I love it, to be honest. I'm very fortunate, like I live and work in East London, but I can cycle most of the way through parks and so on.
Oh, that's really
Uh,
nice.
but also, no, I mean, one of the things right now, you know, more and more coming to a head is, you know, eating less meat.
Hmm.
You know, I think a lot of my childhood friends would be staggered if they realised that I'm virtually a vegetarian now, and hopefully I will summon up the courage to fully take the plunge. But yeah, other than that, is the, you know, the usual, just being as economical as possible, buying the most energy efficient things we can,
Yeah.
trying to reduce packaging. You know, we're buying a lot of fruit and vegetables from kind of local markets instead of getting lots of plastic.
Hmm.
So the obvious things, we're not flying. You know, we've almost not flying. You know, we're doing quite a few UK holidays now, or taking ferry. So really trying to cut down on the emissions in that way.
That's awesome. Yeah, and it's amazing. I mean, there's so much to see in your own home country, that
Yeah, yeah. Oh, it's
one
insane. Yeah, it's insane. If you talk to the average Brit, you know, they've been halfway around the world, but they've kind of never been to Wales or something. It's just
exactly, yeah, or some other relatively large parts of the UK that seem pretty obvious to
yeah.
visit. But that's really cool. That's I'm impressed because, yeah, kind of saying, we're not going to fly. It takes. I think there's an element of, we're taking a stand here, and we're really going to follow through on that.
Yeah, it was a big decision. You know, the whole family love traveling, and
Right.
you know, flying is really the only practical way you're going to, you know, if you're going on a 2 week holiday, that's the only practical way you're going to get any kind of distance. But no, we're looking. I probably I shouldn't say as if we haven't committed yet, but we're looking at a scheme for the company where we're looking at awarding extra days leave if you don't fly, so you can get 2 travel days to give people some extra a chance to get somewhere a bit more exotic without
Yeah.
acting too much on their holiday.
Oh, that's really cool. That's a great thing to do, I think. That's awesome.
It's called Climate Perks if you want to have a look. They seem like a good bunch.
Climate perks. Oh, excellent. Yeah, I'll check it out. Thank you for that. And finally, where can people learn more about the work you're doing, with Demand Logic, and if they're interested in reaching out to you, if there's anyone listening to this who does run a building and wants to learn more, what's the best way to learn more?
Obvious one is our website. Also, our LinkedIn feed is, you know, reasonably active, so that's a good one. We're on Twitter too as well, so all the social media. That's probably the best way to keep track on us.
Excellent. And so the website is just demandlogic.co.uk.
That's right.
And with that web address, do you work only in the UK, or are you also expanding further out?
We are expanding. We've had a few opportunistic looks. We're not actively doing this because we're consolidating our UK position, but we had a couple of installations actually in San Francisco. So
Oh, cool.
in buildings you might have heard of, actually 345 California, One Front Street. Are you familiar with San Francisco?
I mean, I'm from not too far from there, near San Jose, but I don't really know the city that well to be able to tell just by addresses. But I'm sure there are people who are very familiar with that.
Yeah, so some they're quite iconic properties out there, and so
That's
that was
awesome.
great. And it was, for us, it was really a proof that we're kind of relevant,
Yeah.
not just in the UK, but also, yeah, we had a installation in Luxembourg. We're very keen to get around the globe, and I think from all we found, I think similar problems exist, or similar challenges, I should say, exist, globally. So yeah, we will certainly be looking to expand.
That's amazing. Well, best of luck, and keep on reducing those emissions. And I hope you have a portfolio of really well-known companies or buildings all over the world.
Thank you very much.
Yeah, that's awesome. Thank you so much for your time, Mike. Really appreciate it.
It's a pleasure. Thanks for having me.
Thank you very much for listening to this episode. If you enjoyed it, give us a 5-star rating. And also, please subscribe, whether on your podcast app or on YouTube. And that way you can be the first to know about new episodes. Thank you very much, and talk to you soon.